Today I'll be considering question 4 of chapter 1.2. The first part reads, show that if G is a group and if AB to the n is equal to 1 for some elements A, B, and G, and some natural number n, then BA to the n is equal to 1. Then show that if G is a group for which A squared is equal to 1 for any elements A in G, then G is an abelian group. So take a couple seconds to try this out for yourself. Then we'll give you some hints for the first part, then some hints for the second, and then we'll wrap up. Alright, for some hints for the first part, we'll note that we need to somehow construct BA to the n, and somehow we're going to use the fact that AB to the n is equal to 1. So try that and see if you'll know anything. And note that when you're multiplying elements, you don't need to multiply just one at a time. For the second part, we'll note that A squared is equal to 1 for any element A in G. So you can perhaps use more exotic elements than just, A squared or B squared equal to 1. Alrighty then, let's start up with the proof. So AB to the n is equal to 1. We can write that out. Well, first if n equals 1, then we have AB equals 1. That implies B inverse is B is A inverse. But we know that A inverse is equal to A inverse A times, which is all equal to 1. And then we have AB is equal to BA is equal to 1. And then that satisfies our second equation. Well, let's let n be greater than or equal to 2. Then we'll have AB, dot, 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 AB, and then we have this n times. We're going to have that all equal to 1 for some n greater than or equal to 2. Next, we're going to try multiplying on the left by A inverse, and here on the right by B inverse, so right there, B inverse. And we're going to do that on this side, A inverse on the left, A inverse, and now on the right, B inverse. This then implies that A inverse times A is just the identity element 1. So you have 1 times BA, all the way up to BA, times B inverse, which is another 1, but 1 being the identity. This just tells us we have BA, n minus 1 times, n minus 1 times. And that's going to equal A inverse times the identity element times B inverse, but that's just going to be A inverse, B inverse. Cool. And now we'll note that we can either multiply on the left or right of this two-unit expression by BA. We multiply on the left, then we get BA, A inverse, B inverse, which is just going to be the A and the A inverse are going to cancel, and you get B inverse, and you're just going to get 1 on the right, and then you multiply by BA on the left here, or you do the same thing on the right. Let's do it on the right this time. So we're going to multiply by BA on the right of this term and on the right of this term, since we have to specify which side we're doing it on, since we don't know if this group is abelian or not. So then we have BA, n minus 1 times another BA, so this is going to be BA n times, so write BA to the n, is equal to A inverse, B inverse, BA. The B inverse B in the middle here becomes the identity, so you get A inverse A, which becomes the identity again, which is equal to 1. So you have BA to the n is equal to 1. Perfecto. Next, remember we noted we could do this for more complicated elements than just A itself. And since we're trying to use an abelian group, let's put a product in there. Namely, let's have AB squared is equal to 1. Well, that means that AB is equal to 1. And now let's multiply by A inverse on the left and then B inverse on the right. And we're going to do that on this side as well. So A inverse on the left and B inverse on the right. So what are we left with? A inverse A is the identity, BA, and then B inverse is the identity again. So we're left with BA on the right. On the left. We're left with BA on the left. On the right, we're left with A inverse, B inverse. Next, we'll note that since a squared is equal to 1, this implies that a equals a inverse, because a squared is a times a. So a number times something else equal 1 means that something else is equal to its inverse. But in this case, that something else is still a. So we get a is equal to a inverse. So a inverse is a. So we have BA is equal to a, and then b by just substituting b into this formula. And we have the fact that our group is abelian, since any two elements a and b arbitrarily chosen, you can multiply them in any order. And with that, we're done. Thank you.